Hi, I'm Scott Vaughn. In this video, I will illustrate the calculation of true heading used in navigation. This calculation results in the direction to travel for the shortest path between any 2 points on any spherical planet or moon. Thus, the calculation applies on Earth, on the moon, on Mars, and on any other planet or moon anywhere in the universe. These calculations are based on mathematical principles that are very literally universal. I've already done several videos on this topic and each time illustrated the calculations with trips on the fictional planet Kerbin or on Kerbin's moon in the Kerbal system in the game Kerbal Space Program. But these calculations also work for real-life navigation here on Earth. Real-life navigation by airplane or boat. And I thought it'd be fun to illustrate some examples using these principles in Microsoft Flight Simulator. So if you'll join me on this journey that is this video, I'm going to calculate the heading required to travel the shortest path from Montgomery County Community College Central Campus in Blue Bell, Pennsylvania, to the West Campus in Pottstown, which is about 20 miles to the west. And we'll confirm this calculation with Microsoft Flight Simulator 2020. And to do this, I'm planning a flight starting at Wings Field, a small airport just to the north of Philadelphia. Wings Field is very close to the central campus, so we'll fly north from Wings Field, fly over the central campus in Blue Bell, and then fly west to the Pottstown campus, turn around at Pottstown, and fly back a short distance to Heritage Field, which is also in Pottstown, a few miles east of the Pottstown campus. Okay, let's focus in a little bit more on that particular flight path that I have planned. So you can see that we're in the northeast here, Washington, Philadelphia, New York, and just a little north of Philadelphia. We'll zoom in, and the Blue Bell campus is up here. We'll start at Wings Field, which is this airport here. We'll fly kind of this way. We'll take off headed a little bit to the south and west, and then sort of turn to the right and fly north. This will take about a minute and a half or so to get up here to the central campus. So we'll circle around the central campus and then head off in this direction to the west and north a little bit, traveling about 20 miles. This will take about 10 minutes to reach up here to the Pottstown campus. Pottstown campus is right along the Schuylkill River here. And we'll circle around here, and then we'll head back to Heritage Field, and Heritage Field is over here. This is Heritage Field, and that's where we'll land. So that's the plan. So now let's take a look at the mathematics behind computing the direction to travel. I've already derived and applied these formulas in other videos using Kerbal Space Program, a game that's set on a fictional planet and a fictional solar system, and you can find more about the mathematics of navigation on any planet or moon at the website sites.google.com/KSP Math, where there are other examples and videos on the topic of navigation as well as other topics of aerospace, and a workbook that I've written on these topics. And the math here for navigation applies on any spherical planet or moon, regardless of the size of the planet or moon, and so it applies on Earth. Okay, Earth is not perfectly spherical, and no, it's not flat. It's an oblate spheroid. Means it's a sphere that's kind of stretched a little bit in the middle. But that deviation of the Earth from perfectly spherical is not enough to make a significant difference in these calculations here. What is significant here when applying these particular formulas to the Earth is the fact that the Earth's magnetic pole is different than its geographic North Pole, and I'll get to that in a moment. So what we begin with is the latitude and longitude for the 2 points, point A and point B. We're traveling from point A to point B, so this will represent latitude and longitude for our point A, and here we have latitude and longitude for the point B, and we're computing the angle that is the direction, the heading to follow for the shortest distance from point A to point B. And the first thing to do is to compute these values x and y. Now what they represent Basically, what I'm computing with that x and y are two sides of a triangle that results from the geometry of this path. So we want to get from point A to point B, and in that scenario, there's this triangle here that what I need to do is basically find this angle down here at the origin, and that basically corresponds to what the angle is that I need to follow relative to north to get from point A to point B. So again, I went through this in another video, and I didn't want to go through all of the background behind it. I just wanted to give a little sense of what it was about. So that's what that work is right there in finding these values x and y. Now once you have those values of x and y, what this does right here, this is called the two-argument arctangent, and it basically gets an angle based on those x and y values. And after that, what we need to do is take that angle, and if it's a negative, we need to add it to 2 pi or to 360. And then if it's a positive, then you can just leave it. And that's what this mod does. It takes the angle that we get from the two-argument arctangent, and it either leaves it if it's positive, or it subtracts it from 2 pi if it's a negative. And then this part just converts it back to a degree, to an angle in degrees. Oh yeah, and also I just had to point out that this delta phi, this is just the difference in the longitudes. So that's all the math behind it. Let's just run through the calculation to sort of see what it looks like. And then we put that into Excel, calculate the direction for all the points in this trip, and then we can see if it works. So here is Montco's central campus at 40.1756 north, 75.2773 west. The west campus, I'll illustrate just that particular calculation here. And so this is the west campus at 40.2451 north and 75.6565 west, approximately. And what I'm going to do here is take the point A for the central campus, take each of those angles for the latitude and the longitude. And by the way, the longitude, when it's west, I use a negative there. I take those, I convert them into radians. And do that for the point B for the west campus or Pottstown campus. Okay, so what's happening here is I'm taking these two longitudes and subtracting them, getting that difference in the longitude. Then I'm taking latitudes for point A and B and that difference in longitude and just computing that x value that represents this triangle in 3D space that I need in order to find that angle. And I'm doing the same for the y value. It turns out I need the difference in the longitudes, and I need the latitude at point B, the terminal point. Once I have those x and y values, they go into this two-argument arctangent. What happens there is it's basically calculating this angle that happens to be negative. And because that angle's negative, what I need to do is measure it, basically add it to 2 pi. And that's what this mod does. Takes that result with the result of the two-argument arctangent, the angle, and because it's a negative, it adds it to 2 pi, and then finally I multiply by 180 over pi, and that converts it to degrees. So there's the answer relative to the geographic North Pole. If the magnetic North Pole and the geographic North Pole were the same, that's the direction we would fly. But actually on Earth, there's a little bit of deviation between the geographic North Pole and the magnetic North Pole. The geographic North Pole is the axis about which the Earth is spinning. It's perpendicular to the equatorial plane, but the magnetic the magnetic North Pole is offset a little bit, and when you navigate with a compass, the compass doesn't point to the geographic North Pole, it points to the magnetic North Pole, and so you have to make a little bit of an adjustment for that. So what we've calculated here mathematically is what we'll call the true heading. So that is mathematically what the direction needed to travel relative to the geographic North Pole. And the correction comes because of the difference with the magnetic North Pole. And another thing that's just so absolutely fascinating and amazing that I can't resist adding here is look at how the magnetic North Pole has moved over time. And This is an image that you can find on Wikipedia on the difference between the magnetic and geographic North Poles. So now we'll speed up the rest of this calculation here in Excel. And you can see down here at these last 3 rows, I've got this trip from Wingsfield to Monco Central Campus, and from the Central Campus to the West Campus, from West Campus to Heritage Field. And by the way, I'm using the same spreadsheet with the same formulas that I was using for trips in Kerbal Space Program, for points on the planet Kerbin, and for points on the moon of Kerbin. It's the same formula. It's doing exactly the same calculations. And also there's some calculations here for trips on Earth. And what we're getting is the true heading, the heading relative to north, the geographic or true north. Now, in this case, in Microsoft Flight Simulator, I'm going to use the Cessna 152. I'm going to estimate a speed of about 55 meters per second. That translates to about 123 miles an hour. This is the radius of the Earth that I'm approximating. And these are some of the intermediate calculations. You can see latitude, longitude for my starting and ending points. So scroll over a little bit and I find the true heading from Wingsfield to Monco Central is about 353 degrees, so pretty nearly north, going north from the Wingsfield up to the Central Campus. And then we turn west 284 degrees, but that's the true heading. And then about 95 degrees, it's pretty nearly east, but a little south of east, coming back a little, more than 90 degrees, so a little bit south. Coming back from the West Campus toward Heritage Field. These are the times at that particular speed, so it's about 1.5 minutes to go north to the Central Campus. It's about 10 minutes to fly over to the West Campus and about 2.5 minutes to come back to Heritage Field. I've also calculated the distances here, but because I had inputted the radius of the planet. But these are, again, the true heading, and we actually are now going to actually do this in a very realistic simulation, so we need to correct for the actual magnetic heading, which is included in the simulation in Microsoft Flight Simulator. So now I'll jump over here to this website, Sky Vectors Aeronautical Chart. It's free website. You can Google or go directly to skyvector.com. And I've actually put in these 2 airports here just so that it could give me this particular route. Well, it actually just changed it a little bit so that you could fly to this point and then to this weather station and then get to the Heritage Field. But all I really am looking for here, I mean, this is going directly from Wingsfield toward Pottstown and then taking a turn here. But the reason I'm pulling up this navigation chart is because it has this dotted line, which is called an isogonal line, that tells me the correction I need to include from the true north heading, the true heading, to the magnetic heading. So we calculated the true heading, but we actually follow the magnetic heading, and that's 12 degrees is what it says right there. 12 degrees is the correction. So it doesn't change anywhere here in Pennsylvania. It's pretty much 12 degrees everywhere. You'd have to go pretty far outside to actually see that change, and it's not visible here on this particular map. So we'll just use that 12 degrees to make that adjustment in all of those angles. This is a website, that's like a program, an app called Little Nav Map that is free, and it works with Microsoft Flight Simulator. It loads in all the landscape data from Microsoft Flight Simulator. So it's very accurate map here. This is Philadelphia. I've got New York up there, Wilmington, Delaware, Baltimore there. So we're just a little north of Philadelphia, right? And I've actually plotted out the trip in this program, Little Nav Map. And what it's telling me is that the magnetic heading is about 4 degrees and the true heading is 352, very close to what I had calculated, saying 284 for the true heading and 296 for the magnetic heading. And then coming back 95 for the true heading and 107 for the magnetic heading. And so that's really just exactly what we got in these calculations for the true heading. And so I'm making these adjustments here where I'll say from Wingsfield to Montco, I had a true heading of 353 degrees, add 12 and you get about 365 degrees, or about 5 degrees or 4 degrees as it showed there in the little nav map for the magnetic heading. To go from central to west, we calculated a true heading of about 284. We add that 12 for the magnetic variation and we get 296 degrees for the magnetic heading. And from west to Heritage Field, it was 95 degrees true heading, but add 12 and you get 107 degrees for the magnetic heading, which is what I'm seeing there. Here with the flight plan displayed, we could actually look for some waypoints that we can identify visually as we fly along. So here's the path from Wingsfield up to Montco Central. One of the things after we leave Montco, we'll look for that 476. We'll pass over 476. And then we'll expect to fly over this Perkiomen Valley Airport right here. And right after that, maybe we'll notice the, what is this, the Perkiomen Creek. And we can look for Ursinus College, maybe a little bit to the left right after the airport. Maybe we'll notice this high school over here. Some shopping. Then we can look for the next thing to really clearly identify will be 422. And as we're coming in this direction, we will definitely notice this Limerick nuclear power plant. That'll be off to the left as we're coming in toward Pottstown. And we'll notice this quarry here, Sanatoga Quarry. We'll pass over the Schuylkill. It'll kind of bend right there underneath us. Pass over 422 again. And as we're coming into Pottstown, we'll notice all these buildings, which are like steel processing, manufacturing in Pottstown. And then, we'll look for the Pottstown campus and turn around and see if we can come back. We'll notice the shopping center here. This is Philadelphia Premium Outlets and a Costco. So we'll look for that a little to the right of the airport as we're coming in. Yeah, so that's it. That's the plan. Okay, ready to go? Let's do it. I've got a headset, so obviously I'm ready. Ladies and gentlemen, this is the captain speaking. That's the Montgomery campus off to the left. Okay, we're now on our way to the Pottstown campus, the Montgomery West campus. Right, we're just about passing over the Perkiomen Valley Airport right here, and you can just begin to make out the Limerick Nuclear Power Plant cooling towers just up ahead. And there's the West Campus. I can just see it off the right wing there. Now we want to land at Heritage Field. Okay, that's it. We made it. Thanks for coming along.